Welcome everyone to another calculator tutorial specifically on the TI-84. Today we're going to be talking about some graphs and tables, so let's get started. First and foremost, I want to make sure that my calculator is set up for success, at least for me and how I like to do it. So I'm going to go to the mode button and I'm going to make sure that I go from full to graph table so I can see all of my lovely information all at once. Besides that, we're going to keep everything as is. And I'm going to go to the y equals screen. So to play around, let's play with a function that I think is one of my favorites. That is the sine function. Why? One, it's beautiful. If you ever take pre-calculus, gorgeous. So if we graph this function, we see it's a nice function. It's continuous. It has lots of maxes, lots of minimums, infinitely many so. So you can see that it graphs the function, and then I have my table of values over here. Now, for a sine function, if you're familiar with it, this table of values isn't very useful. So the first thing I'm going to show you is how do we program this to give us a table of values that is useful for us. So to do so, we need to set up our table. If we go to second window, we get table set up. We can pick where the table starts. 0 is fine for us. And then how much the table changes per input. One doesn't really make sense for a sine function, but what does make sense would be pi's, pi over 2's, pi over 4's, pi over 3's, pi over 6's. All of those make sense. So let's start out with pi over 4. And if we go back, we can see we have this lovely table of values. We have some really nice y values that go along with it. 0, root 2, 1, root 2, 0. Symmetrical, beautiful, gorgeous. So from this might be useful, or we could set up the table to be a little bit different. Maybe we want to do it pi over 6 instead. And doing so, we get another lovely table of values. So you can really choose how you want your table to be set up, where it starts and what the change is. Sometimes you want to change it by 1, maybe you want to change it by a half. Really doesn't matter. It depends on the function you're using, right? If I go back to table set, I don't really have my students use this part of the table setup a whole lot. Not going to lie. It's nice to have, but it doesn't have a whole lot of overall use, right? You look at it, it's pretty great. If I go from independent auto to independent ask, that's where I can get a little bit more bang for my buck from my table. If I go back to table now, I can actually pick the x values, and then it'll automatically calculate and tell me what the y value would be for that specific x value. So if I could pick 0, I could pick 2 if I wanted to. I can pick 3 pi over 4. I can do whatever I want there, right? And I can actually go up on my table and it'll show me where on the graph that point is, which I think is really, really nice. If I scroll over, it can also tell me with more accuracy what the decimal approximation would be for that given input. So as you can see, we can get some really, really nice answers here, more than just the couple of decimals they give you in the table itself. If you have one specific x value that you're wanting to input and you don't want to have to make a whole table about it, instead of going to graph, if you go to trace, you can actually be, I want to evaluate this at -5. You can just type in -5, enter, and it'll give it to you. You can also scroll around by going left and right, and you can see it increments by a small margin and shows you specifically where that would be, the x and y's to go with it. Again, I don't really use this option very much because those numbers really come out of nowhere. I like to either pick my own or use very specific numbers based off of our functions. So that is a little bit of a rundown on the table itself. Let's talk more about the graph. So one, your graph starts by a default window of -10 for the y, +10 for the y, -10 for the x, +10 for the x. For right now, that's good. If I wanted to see this more exaggerated, if I wanted to see my sine curve in a little bit more detail, I could go to Window And instead of making my y min -10, my y max 10, I could make it -2 and then +2. And then for me, oh, wrong one. So this is where messing with the calculator and trying things out would be a good idea. So instead of modifying the y's, I actually modified the x's. I want to modify the y's instead. And you can see I see a little bit more of that sine curve. I see it in a little bit more detail than I saw it before. So this is great and all. But what if we have a function that is just very strange, very weird? Let's do 20 sine x. So as you can see, I can barely see the function now. How can I see the function a little bit better? We can adjust the window, and I definitely recommend messing around with it and getting a little bit better at it. We can also zoom. This is something my students gravitate towards at first, is this zoom in, zoom out. If I go to zoom out and then just hit enter, you can see I don't have any control over it. If I hit enter again, it'll zoom out again. Oof, right? Zoom in would do the exact opposite. Again, I don't really have much control. It kind of just zooms in, zooms out by a predetermined amount and not really specific to your function. If you'd like to zoom a little bit more specifically, with a little more specificity, if you go to zoom and scroll down, you can find zoom fit. Zoom fit, the graph kind of calculates what would be the best x and best y values to use to see the function in as much detail as you can. So in this, it picks it for us, and again, you can see, we can see almost the entirety of the curve. It does cut off a little bit. If you notice down here, we're missing like the tips of our sine function. If we go to window, we can see that they made the y min and x min and x max -10 to 10. The y min and y max are -19.99 to 19.99. With 20 as my, coefficient there, I know that it's going from -20 to +20. So let's change this to make it so I can still see everything. So I like to go a little bit below and a little bit above so I see everything. Now you'll notice that we have some other options here in window itself. We have the x scale and the y scale. So if I change this x min and x max from 0 to 2 pi, it might not make sense to scale by 1. I might want to scale by quarters of pi. And since I'm going from -25 to 25, I essentially have 50 x values I'm looking at. So instead of scaling by 1, let's scale by 5. If we graph now, we can see that the tick marks that they use to increment have been modified to work a little bit better with our function itself. So we can see we have 0 to 2 pi and every quarter pi in between. And then we go from -50 to +50, and we're incrementing by 5 each time. Or 25. Oof. So again, if we trace, we can see we have a nicer window to look at. Something else that you might want to do in terms of zooming in and zooming out, one thing I really like is this zoom box. Sometimes you have a really weird looking function and you only care about looking at a small part of it, or there's just so much information. If we do zoom box, we can go and we can essentially pick one corner of a rectangle, and then we're going to draw up a rectangle. So as you can see, we're starting to see like a line form here. It's not letting me like repeat hit, but that's fine. And then we can extend a rectangle, and this will become the new window. Where that box is covering will be my new window. If I hit enter, boom. So this can be nice if you're looking at a very specific detail of your function. You can always go back by readjusting your window, or you can hit zoom 0 to do the zoom standard, or the zoom fit. Now, you'll notice there's some other zooms here as well. Some other ones that I really like are zoom trig. So what zoom trig does is it adjusts the window in terms of the X values to be more aligned with trig graph paper. But in doing so, it also shrinks the Y's. So if we change this back to -25 and +25, we can see that it does fit in terms of like the X values better with our sine function. Something else we have zoom 6, which is standard. If you want to go back to that 10 by 10 window, or -10 to 10, -10 to 10 window, zoom 6 will fix it. So if you have some really weird formatting, zoom 6 fixes the entire thing. Now, let's go one more time to changing this up. Let's do -2 pi to 2 pi. Ooh. Try that again. -2 pi to 2 pi. And then we'll change this from -25 to +25. There we go. So you can see if I don't adjust the increment, then the tick marks are going to show up as normal. So it's really up to you. We can actually play with this function a little bit more with the calculate tool that's built into your calculator. So if you go to second trace, we have some options. Calculate 1 is just picking an X value and outputting a Y value. You can already do that by hitting trace and then enter, and it does the exact same thing. So calculate 1 really doesn't help you. Zeros, on the other hand, are very useful. If we want to see where a function crosses the y-axis, we can go to the left of it, then we can scroll over to the right of it, and as long as it crosses the x-axis in between those two, it will calculate the x value of that intersection. You might see a little bit of weirdness, like an e to the negative some odd thing. It essentially just means 0. So if you see some weird thing here or some weird thing here, just use your best judgment. But here it says pi, which makes sense because it's a sine function. Now, if I wanted to find this 0, I would have to change where I put my bounds. Something else cool that you can do is you can actually use the keypad to pick where your bounds are. Let's say that I want to do from -1 to +1. I have a 0 between those, hit enter, and it tells me 0 at 0, 0. So if you want to do that, you can use the keypad, or you can always scroll left and right, and that's perfectly fine as well. You can only have one 0 in between. It has to have a 0 in between, or it's going to give you some sort of error. Maximums and minimums. If you want to find a relative max or min, in this case I picked maximum, you have to go to the right side of your maximum, and then the left side of your maximum, my bad, and then the right side of your maximum. It doesn't have to be equally spaced. As long as your one's on the left and one's on the right of it, it'll be perfectly fine. It'll tell you the x and the y coordinates of your maximum, which can be useful for calculus or word problems, this, that, or the other. Like, very useful stuff. We can do the exact same thing with the minimum, and we can use the kind of cheat code we used before with using the number pad. I can use like -3 and 0 and find the minimum that way as well. Perfectly fine. If I go to calculate again, the fifth option is intersect. To intersect, I need to have another function. So let's go to y equals, and let's graph something strange like x squared. Not very strange, but you get the idea. If we graph, we have 1, 2, and maybe 3 intersections. We really can't tell. So let's see if we can find these intersections here. Second trace, intersect is 5. And what we're going to do is we're going to scroll close to one of the intersections. Now, the cheat code of using the number pad doesn't work with the intersect tool. I did find that out. So as long as we're close, we'll hit enter, enter, and then enter one more time, and it'll find the intersection. Now, if I wanted to find this intersection instead, I just have to make sure that I'm scrolling closer to that intersection than the other. So if I want to find that other intersection, I'm going to scroll left, get closer to it, enter, 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 0, 0. We don't know if that's an intersection, right? So we could use the zoom box. We could use the zoom box to try to figure that out. Oh, it's going to be annoying, isn't it? Well, we'll try. There we go. There we go. So we can zoom box this. This is a good idea for when and how to use it to see if we have some sort of intersection there. Zoom in, and doesn't look like it. So using the intersect tool would just give us 0, 0, since that would be the closest intersection. So some ideas on how to use your calculator. You can mess with some of the other zooms as well, but zoom 6 is really just fixing it back to normal. And we can get rid of, let's get rid of the sign. So we'll play with the x squared. The next options are dy over dx, which is the derivative, and then the integral of f of x dx, which is the antiderivative or the integral of. These are calculus concepts. The derivative is finding the instantaneous slope. So I can either scroll to find whatever x value I want to evaluate at, or I could pick one. We could do 3. And it'll tell me the derivative when the x is 3 is 9. So the slope of the tangent line there is 9 up for every 1 to the right. Fantastic. We can also do the integral. So the integral is the area under the curve. So I could find the area under the curve from 0 to 2, and it will shade it in, and it tells me that the area under that curve is 2 2/3, or 2.6 repeating. Very cool. So that's it for the calculate menu. You'll notice we do have format. There are some things that we can do. When you get to a certain point, you might learn about polar graphs, and polar graphs are not vertical and horizontal lines coming together to make a coordinate system. It is a series of ever larger circles measuring its distance and an angle from a center point. If we look at the graph for this one, it doesn't really change much. So we'll turn that back on. You can turn all of this stuff on and off and see how that works. So I recommend definitely playing with it. And remember, if you ever mess anything up, you can always reset the memory if you're really worried about it. We can turn on a grid. We can actually make some grid lines. So it's more like normal graph paper. So if that helps, you can always do that. You can change the grid color. So you have some options there. The axes, you can choose to either turn the axes on or off. You can put labels on them. You can change the color. We can make it magenta if we want to. We can put some labels on the axes. Go back, we see Y and X. Although I'm not sure exactly why they're there. That's perfectly fine. And all of this other stuff. So you can see some of these things aren't really changing a whole lot, and that's okay. Border colors, change the border around the graph. And then one of the things my students love to do is turning on background images. For some reason, they absolutely love the sync, so they might put on the sync. So if you ever get a calculator that has like a background picture on your calculator, you can always hit Format and then change the background image back to off. You can also have it detect asymptotes. Right now, that's like the vertical line it might draw. You could have that off as well, so you might turn off some of that weird distorted behavior. For example, if we graph the function 1 over x plus 1, we'd have a vertical asymptote at -1. Zoom 6. You can see we'd have a vertical asymptote there. We can turn off detect asymptotes. Not exactly sure what it'll do for us, but Ooh, I'm struggling. Ah, so if it detects an asymptote, it won't draw this vertical line, essentially, which is a newer feature. Back in my day, they always drew that vertical line there. So it can detect an asymptote and just not draw that piece, which is honestly really, really nice. The last thing I want to show you is what happens when you try to graph sine, cosine, and or tangent when you're in degrees. So if we switch our mode to degrees instead of radians, and we go back to y equals and we have sine x, and then we graph, you'll see that we don't have a whole lot of the behavior we had before. We don't have those beautiful curves. In fact, if we go to zoom, trig, we do end up with those beautiful curves. What's happening here? What's the difference between this one and the other one? Well, look at how big my x values are. This is using degrees, so my window has to cope with that. So if you zoom trig for this one, it'll actually make your window, your x min and your x max, more in line, because again, in order to complete a whole cycle, it goes from 0 to 360 degrees, which happened in just 2 pi before. So be careful if you have your function in degrees that you might have really weird distortions there. So that's why typically we graph our trig functions in radians. That is it for this one. If you have any questions, please let me know, either in class or in the comments. Other than that, I'll see you in the next video.